Let's go ahead and do a few more. So this one, I'm going to go ahead and factor and take out my greatest common factor and then find my information. So there are no holes, but we've got two vertical asymptotes this time. One at x equals 0 and one at x equals 3, because remember vertical asymptotes are right here. So we've got 0 and 3. Let's go to our horizontal or oblique. So if I divide 2 by x squared, you have, it doesn't simplify. There's still an x in the denominator, so that's the example where y is equal to 0. I should use a different color. So there's that. Now, because there are two vertical asymptotes, we're actually going to have 3 curves, because there's like 3 parts of the graph. Now, x-intercept, this is tricky for a lot of people, but there is no x in there. 2 can never equal 0, because we're just trying to find the 0 of the numerator. Therefore, there are no x-intercepts. And then y-intercept, if you plug in 0, there's no constant, so you actually get 2 over 0, which means there are no y-intercepts. Absolutely none. So this is why this problem is fantastic. There's no x-intercepts, there's no y-intercepts, and we literally have no coordinates. We have to, no matter who you are, use a table to finish figuring this one out. So in order to do this one, I'm just going to pick a section. I don't care what section I start with. Let's say I say section A, so I'll do section A, B, or C. So on the far left, let's plug -1 in. So we're just plugging that in. You don't have to write this out, but I get 2 over 1 plus 3, so 2 over 4, or 1/2. So I go to -1, positive 1/2. Now remember, I know there are no x-intercepts, so I know it's just going to follow the asymptotes without crossing the x or y axis. Let's go ahead and do another one. So that was for section A. Let's do one for, well, and actually we don't have to do one for section B, but you can if you want. So you could pick like 1, and then do 2 over 1 squared minus 3 times 1, which is -1, so 1, -1. But let me explain why I know I don't have to. So if you look at the multiplicity of each one, the multiplicity of the x equals 0 is 1, meaning the arrows will go opposite directions. The multiplicity of x minus 3 is also 1, so it's odd, which means the arrows will go opposite directions. Therefore, I knew since the arrow was already on this side going up, on the other side it had to go down. Now you might be asking, how do you still know what's going to look like? Well, remember, it can't have an x-intercept, so I can't go through or touch the x-axis. So I know it has to somehow come back down toward the next asymptote. And then, likewise, rather than plugging in a value for C, I already knew that these arrows have to also go opposite direction. And currently this one's going down, which means the other one has to be going up, so it has to be in the above region, and it can't cross through the x-axis, or else you'd have an x-intercept. So I'd have my section for C. But if you're really not sure, plug in like 4, plug it in, minus 3 times 4. So you get 2 over 16 minus 12, or 4, so which is a half. So you'd have a half. So I was a little off, well, pretty off. But remember, these are sketches. You don't have to be right on. But it's still in the same region. Let's go ahead and do another one that's kind of fun. Well, I think all of them are fun. I don't know why you guys don't, but we're going to have fun. So I'm going to go ahead and factor these. These actually factor to x minus 1 squared and then x plus 1 squared. So once again, no hole at all. But we have a vertical asymptote at x equals -1. So this is our vertical asymptote. We have an x-intercept at x equals 1. And notice that it's squared, so it's going to bounce on that. So that's pretty important. And then we've got a y-intercept of 1. So 1 over 1 is 1, so that's right here. And then we've got a horizontal or oblique asymptote this case horizontal, because x squared over x squared is just 1, so it's y equals 1. And what you're going to notice is this one is kind of funky. Now, you can actually figure out this one, but once again, you might need to plug some points in. If you need to, plug some points in so that you can kind of figure out what it looks like. But this is a prime example of one that's actually going to cross through the horizontal asymptote. Remember, horizontal asymptotes are guidelines, not rules. So they're more like guidelines than actual rules. I know that these two have to connect, and it has to bounce off and then follow this asymptote. Whether it follows above or below, it doesn't matter for our sketches, because, I mean, it does matter, but for our sketching purposes, it doesn't matter. And then I can't go back down because then I'd have another x-intercept right here. So I'm actually going to go up like so and call it good. Now on the other side, we've got to figure out what's going on. So we have this vertical asymptote. It's squared, which means the arrows actually have to go same direction, whether they're both going up or both going down. And so I know my other curve will be somewhere in this region following these asymptotes. Whether it's the exact position, it doesn't matter. If you want exact position, you're going to have to start plugging numbers in and find exact position. But I know it's going to be something like this. All right. Let's see if I want to do another one. That one seems fun. That one seems fun. Let's do this one. This is our final problem. So this factors, I'll go ahead and just factor it all for you. The bottom factors, I'll also factor that like for you. Once again, no holes, but there are two vertical asymptotes. So our vertical asymptotes will be at -3 and +3. And then we have x-intercepts. I was ugly, sorry, at -2, +1, and -1, and they're all crosses because they're all odd exponents. So -2, +1, -1. Ooh, that's fun. And the y-intercept will be very helpful in this case. So y-intercept will be the constants. So you're dividing the constants because you're just plugging 0 into all the x's. So here's our y-intercept. So -2/9 or +2/9. Right. That was not 2/9, but close enough. And then last but not least, you know, our favorite part. Here, I'll do a different highlight. We're going to do our horizontal or oblique. In this case, it's an oblique asymptote because x³/x² is x. So I know it's y equals x, but we need to find our constant. So I'm going to go ahead and do some quick long division. And you don't have to go very far, we just have to find the constant. I know it's x. X² times x² is x³. X times -9 is -9x. Oops. And I'm subtracting. And so I'll have 2x². I actually don't care about anything past that, because this first term is going to tell us what our constant is. 2x² divided by x² is 2. So we have our +2. So I'll go ahead and draw that. I should probably use a different color for the coordinates so that you can see where I'm using coordinates versus asymptotes. So it's +2, so that's our y-intercept, so right here. And the slope is up 1/1, up 1/1, so on and so forth. Notice it did just go through one of my x-intercepts, and that's okay. Remember, horizontal oblique asymptotes are guidelines, not actual rules. Now, I know all these have to cross, and I know these three have to connect. So it's going to cross through like so, and then cross and go back up. And then our quick little trick with vertical asymptotes, which I forgot to mention earlier. Both are odd exponents, so the arrows should go opposite directions. And I just draw them opposite. It doesn't matter if I start with the bottom or up. So it looks like so on this one, because it needs to be in the bottom region, since it's opposite. This one will be in the top region, since it's opposite of that other one. And there you go.